So now we're gonna find the local minimum and local maximum of this function. And the first thing we have to do is to derivate this function, and we're gonna get this. So now what we're gonna do is to put that this function is equal to 0, and we're gonna clear x. So by doing that, we're gonna get this division, and if we put it in the calculator, we're gonna a fraction that is here, and what we're gonna do now is to put this power of 2 to the other side, and that means that the value of x is 1.46, and because we made this root, we're gonna have that one positive 1.46 and one negative 1.46. The next thing we're gonna do is to put these results and put it in the first function and see what we're gonna get. We should get the y coordinate, so we're gonna see. So now we got the first y coordinate, that is this one, and now we're gonna evaluate the second x value. And now we got the other y value. Now the thing that we're gonna do is to derivate. We're gonna get the second derivative of this function that was here, and our result is 3x. So now what we're gonna do to know which coordinate is maximum and which coordinate is minimum, it's to evaluate the second derivative with our x value. So the first one will be 3 times 1.46. And due to this value that is negative, means that the coordinate of minus 1.46 is maximum. And now if we evaluate the other value, we will get a positive number, so that means that this coordinate, the coordinate where 1.46 is positive, is minimum. So now we've got a local maximum and minimum. Here are.
So now for the part B of the exercise, we must obtain the point of inflection, and in order to do that, with the second derivative, we make that equal to 0. And for doing that, I'm going to use the function equa here of my list, and then in the part solver, I'm going to write it. And now we have that x is 0, like here. And after that, we must substitute the result in this part as we have here. And now I'm going to do that in the calculator also. Here. Which means that is 0 because, well, obviously we multiply that for 0, so it gives us 0, and now we have that the point of inflection is 0 and 0.
First, what is a negative rate of change on a graph? Well, this is represented by a downward slope, and if we draw a line between 2 points on the graph, if the line descends from the left to right, this indicates that as the variable x increases, the variable y decreases. This is a behavior that is common in functions. And well, because of this, now we are going to take out our calculator and go to the menu part to go and click the graph one. With this, we are going to use the previously function that my classmates have already worked with, and it's 0.5x over 3 minus 3.2x. Now, when we graph this one, we can have that our graph go and have positive parts and negative parts, and well, that has a maximum point of minus 1.46 to 3.115. Then we have going through negatives, but we have an inflection point on 0,0. No, that's important. We have the minimum point of 1.46 and minus 3.150. No, so with this information of the maximum and minimum points, that we can know that the value of the x is greater than minus 1.46 and less than 1.46.